moving to the next example, right? Example 4. So that will help us to see the difference in values. So first, it is asking us to compute differential of y and delta y's on this particular curve, and from x equal to 2 to x equal to 0.3. So first thing, when we look at this, we know that the change in y, right? Let's find that out because that's easy. That's basically talking about the change in y value, which is y evaluating at 2.03 minus y evaluating at 2, right? The change in y value of the function. That's what this delta y means. So when I use my calculator and then approximate it, so make sure you put it into radian modes, because this is the sine and cosine will be in radian function. So this gives me 0.0835812 dot dot dot. Right? I got this. Now, what we want to do is we want to look at what is the differentials. So to talk about the differentials of these functions, right? And I need to look at my y as a functions of x. So therefore, my differentials of y, that will be f prime of x times with dx. So from here, what we need to find out is what is my dx is going to be. So remember that dx, that is basically talking about the delta x, right? Which is, in this case, is 2.03 minus 2. That gives us the value of 0.03. And now we want to find out the differential functions, right? So that I can basically continue. So where are we centered? Centering at 2. That's what we need to remember. Therefore, dy, that is equal to derivative of the functions, which is derivative of cosine, is negative sine of everything inside is the same, times with, using the chain rule, taking derivative of inside, which is 2x plus 0, and then times with, not times with, minus derivative of x, that would be 1, and finally multiply with dx. So now differential of y, simplifying a little bit, that will give me negative 2x sine of x squared plus 1 minus 1 and times with dx. And what are we evaluating? We are basically what? Evaluating at, that, right? The differential at 2 with the delta x, dx become 0.03. So that's why in the beginning I mentioned it before, this differential of y is dependent variable respect to x, right, where your initial point is, and your delta x. So when we are evaluating this is basically dy is evaluating at x equal to 2, and the delta dx is equal to 0.03. So which give us, when I put it into the formula, right, so that will become negative 2 times with 2, and then sine of 2 squared plus 1 minus 1, and 0.03. And when I compute this, this will give me approximately 0.08507 091 dot dot dot. So you can see that the change in y value of the original functions approximations are up to 2 or 3 decimal points accuracy right here. Close to 2 decimal point accuracy for this one. So that's basically like later I'm interested in is using this idea together with what you learn in the chemistry or physics lab, finding out the relative error to see that your error is a significance or not, to talk about conclusions on your project or your researches and so on and so forth.